solving harder trigonometric equations. So here we're just going to jump straight into some examples. So we're looking at solving cos 4x minus cos 2x equals 0. Inside the domain where x is between 0 and 2 pi. So we can see that we've got a cos 2x and a cos 4x, and it implied that double angle formula for cos would come in handy here. So let's just write that down. So we're going to have cos 2x equals cos squared x minus sine squared x. But looks like we'd like to keep everything in terms of cos. So we'll use the 2 cos squared x minus 1 form. And we have cos of 4x. So you notice in double angle, as long as you have a value x and double it to 2x, it'll hold true. So this means that cos of 4x would be the same as 2 cos squared of 2x minus 1. And we're going to go ahead and sub that in for cos 4x. So we're going to have 2 cos squared of 2x minus cos 2x equals 0. So if we got the minus 1, let's throw that in there as well. And now we can go ahead and let u equal cos of 2x, or if you feel comfortable factorizing the quadratic equation, you could in terms of cos, but that's just going to leave us with 2u squared minus u minus 1 equals 0. And we can solve this quadratic equation in terms of u. So we have a non-monic here, so we can write it as 2u all over 2 equals 0, times the 2 by the negative 1 to get minus 2. So we need two numbers that multiply to minus 2 and add up to minus 1. So it's just going to be minus 2 and plus 1. We can factorize the 2 out in the first bracket, so we get u minus 1 and 2u plus 1 all over 2 equals 0, and the 2's cancel out. So we know that u has to equal to 1 or minus a half. But we let u equal 2x, cos of 2x. So we have cos 2x equaling 1, or cos 2x equaling minus a half. And since we're solving with the domain from between 0 and 2 pi, and we've got now cos of 2x, we'll expand our domain by timesing everything by 2. So we're looking for values of 2x between 0 and 4 pi. So we need to go ahead and use our unit circle to solve these. So in our first one, we're looking of values of cos that are positive, which is going to be in the first and the fourth quadrant. So they're going to be equal to whatever our base angle is and 2 pi minus our base angle. So let's go ahead and find that base angle for this one here. So our base angle is just going to be the inverse cos of 1, which is just going to be equal to 0 and 2 pi. That means our answers for 2x are going to be our base angle itself of 0 and 2 pi, and 2 pi minus our base angle. So we get 2 pi minus 0, which is 2 pi, or 2 pi minus 2 pi, which is 0. So we can see we've doubled up on the answers, so we can scrap those. We've already accounted for them. And then we have to go make another revolution around the circle because we've expanded our domain. So we just add 2 pi to both of those answers. So 0 plus 2 pi is 2 pi again, but we've already got that answer. And 2 pi plus 2 pi is 4 pi. Then dividing all of those by 2, we're going to get 0. 2 pi divided by 2 is pi, and 4 pi divided by 2 is 2 pi. So we get all of those solutions for that one there. Now we need our base angle for our other one. So we're going to do the inverse cos of a half. So we get our base angle equaling pi on 3. And since we have a negative value for cos, this time we're looking at answers in the second and third quadrant, where those answers will equal pi minus the base angle and pi plus the base angle. So our answers for 2x here will equal to pi minus pi on 3 and pi plus pi on 3. And again, because we've expanded our domain, we need to add 2 pi to both of those answers. So let's just find those answers first. So we have pi minus pi on 3 will be 2 pi on 3. Pi plus pi on 3 will be 4 pi on 3. Then we're going to go ahead and add 2 pi to both of those answers. So we're going to get 2 pi plus 2 pi on 3 plus 2 pi on 3 is 8 pi on 3. And 4 pi on 3 plus 2 pi is 10 pi on 3. Dividing all of those by 2, we're going to get 2 pi on 6, 4 pi on 6, and 8 pi on 6, and 10 pi on 6. And we can simplify those to get pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. So then we get our final answers for x being 0, pi on 3, 2 pi on 3, pi, 4 pi on 3, 5 pi on 3, and 2 pi. Let's look at another example. So we're solving sec squared x minus 2 tan x equals 4 when x is between 0 and 2 pi. So the first thing we want to do here is change our sec squared in terms of tan squared. And we know 1 plus tan squared x equals sec squared x. So we can sub that in. So we're going to get 1 plus tan squared x minus 2 tan x equals 4. So we get tan squared x minus 2 tan x. Let's bring the 4 to this side. So we'll get minus 3 equals 0. And now we just have a quadratic equation in terms of tan. So we could go ahead and let u equal to tan x. So we just have u squared minus 2u minus 3 equals 0. We can solve this quadratic equation. So we're going to get we're looking for two numbers that multiply to -3 and add up to -2. And that's just going to be -3 plus 1, which means u has to be equal to -1 or 3. But we let u equal tan x. So that means tan x must equal -1 or tan x equals 3. So then we're going to need our unit circle to help us solve these equations. So we're looking for, in our first one, we're looking for values of tan that are negative. And that's going to happen in our second and fourth quadrant, where we're going to get pi minus our base angle for our second quadrant, or 2 pi minus our base angle for our fourth quadrant. So we'll find that base angle by doing the inverse tan of 1. So we disregard that negative, and we get our base angle equal to pi over 4. So that means our answers for x are going to be pi minus that base angle of pi on 4 and 2 pi minus that base angle of pi over 4. So we're going to get answers for x equaling pi minus pi on 4 is going to be 3 pi on 4, and 2 pi minus pi on 4 is going to be 7 pi on 4. Now, for our other answer, we don't have a nice value, so to get our base angle, we're just going to go the inverse tan of 3, which we get theta equaling 1.249 radians. So we can't write it in a nice answer. We could leave it in exact form as inverse tan of 3, which we might do that. So then we need answers for tan that are positive, and that's going to happen in our first quadrant and our third quadrant, where those answers are going to be the base angle itself and pi plus the base angle, which means those answers for x are going to be the base angle itself, which is just the inverse tan of 3, and pi plus the base angle of the inverse tan of 3. So our final answers for x are all 4 of 3 pi on 4, 7 pi on 4, inverse tan of 3, and pi plus the inverse tan of 3. Let's look at one more example. We want to solve for x of 2 cosec theta minus 4 cot theta equals 3 in the domain where x is between 0 and 360 degrees. Now here we're going to use our t-formula results to solve this equation. Now let's go ahead and write those down. So we've got, the definition is that if t equals tan of theta over 2, we can get expressions for sine, cos, and tan of theta. So sine theta would equal to 2t over 1 plus t squared. Cos theta would equal 1 minus t squared over 1 plus t squared. And tan theta would equal 2t over 1 minus t squared. So let's go back to our equation and just express it in terms of sine, cos, and tans. So we can write this as 2 over sine theta minus 4 over tan theta equals 3. Let's go ahead and sub in our t-formula results. So we're going to get 2 over sine theta, which we can write as 2t over 1 plus t squared, minus 4 over tan theta, which is 2t over 1 minus t squared, and this all equals 3. So we can tidy this up a little bit, because we have a number over a fraction. So we can say that this is actually just going to be, we can think about the 2 as 2 over 1 and the 4 as 4 over 1, and we can say we have two fractions on top of each other. So we can say the outer terms multiplied together over the inner terms multiplied together. So we'll get the outer terms, which are 2 times 1 plus t squared, over the inner terms, which is just 2t times 1, which is just 2t, minus again the outer terms, which is 4 times 1 minus t squared over the inner terms. 2t times 1 is just 2t. That all equals 3. Now we can simplify this a little bit by cancelling these 2's and simplifying the 2 and the 4 into a 2. And they have the same denominator. Actually, let's just times everything by t. So then we're just left with 1 plus t squared minus 2 outside of 1 minus t squared equals 3t by timesing everything by t. Then we're going to get 1 plus t squared. Let's expand this bracket so we get minus 2 plus 2t squared equaling 3t. Let's bring everything to the left-hand side. So we're going to get t squared plus 2t squared is 3t squared, minus the 3t over to this side, and then we have 1 minus 2, which is minus 1, and that all equals 0. And we've broken it down to a quadratic equation in terms of t. Let's just go ahead and use the quadratic formula. So we're going to get t equals minus b, so minus 3, plus or minus the square root of minus 3 squared, so b squared, minus 4 times a, which is 3, times c, which is negative 1, all over 2a, so 2 times 3. Tidying this up is just going to give us t equals 3 plus or minus root 21 over 6. But remember the definition of with t formula is that t equals tan theta over 2. So we get tan theta over 2 equals both 3 plus root 21 on 6 and 3 minus root 21 over 6. We can inverse tan both sides, and that's going to give us theta over 2 equals the inverse tan of 3 plus root 21 on 6, and the inverse tan of 3 minus root 21 on 6. And finally, we can times both sides by 2. So we get theta equals 2 times the inverse tan of 3 plus root 21 over 6, and 2 times the inverse tan of 3 minus root 21 on 6. And if you put those in the calculator, that'll give you answers of approximately 103 degrees and 330 degrees. Just one thing to note when you're using the t formula, if you don't get two answers when you break down a t formula question into a quadratic, it's possible that 180 is a solution and you wouldn't have gotten it because tan of 180 on 2 is 90 and tan 90 is undefined. So if you only get one answer, just go back to the original equation and sub in 180 and see if it's a possible solution. And if it is a solution, you have to include it in your final solution.